Well, hello. Those two videos and the ed puzzles you had yesterday were filled with vocabulary. And some of the vocabulary you're familiar with and some you're not. So I want to pull out some important terms that you've just heard and played with a little bit, some directly and some not. So I'm going to give you just a quick vocabulary list. Again, if you know these terms, then I'm not going to ask you to do anything with them. But if you're shaky on them and not quite sure, especially at the end of our discussion today, then I'd like you to go back and use your textbook to fill out some definitions. I think that would be helpful. So we have looked at quite a collection of vocabulary, and they started off with these words, or this word particular called an allele. An allele is just a simple letter that's going to represent the version of a trait that an individual has. We typically use a capital letter and its lowercase form, but that can change depending upon the complexity of the genetics that we're looking at. So we've got alleles, and there can be dominant alleles, and there are recessive. Dominant means it's the boss, it's the one that's expressed if it's there. Recessive means the only way that this particular trait is expressed if that's the only one that it's got. Alleles are typically letters. So we'd say big T or little t. Dominant is going to be the big T, and recessive would be written as the little t. In this case, we're talking about height. So this would be tall, and this would be short. Then we went with some terms that describe the traits. So that would be genotypes. And then how we physically describe the traits would be phenotype. Again, this is a lot of vocabulary. You don't have to be a master of this yet, but I do want you to have a little bit of a reference sheet. Genotypes would be the different combinations. So you could have big T for height, or you could have big T for height, or you could have little t. We won't ever put the little letter in front of the big letter, because when the dominant and the recessive are together, the dominant's always expressed, and the recessive is hidden, so you don't see that. So we'll go with this one first. Phenotype would just simply be the description, tall or short. Phenotype is the physical trait that's expressed, and genotype is the letters representing the genes. Now we also have some descriptions of these pieces. So homozygous and heterozygous. I want to draw your attention to the prefix there, homo and hetero. From our previous study, homo means the same. So that means the alleles are either going to be both dominant or the alleles would be both recessive. So homozygous would be big T, or little t. Heterozygous would be you would have one of each allele. So that's a great starting list of vocabulary. Be careful of this. Make sure that you've got this close by, because we are going to dive into one of the storylines that we looked at on Monday. On Monday, I asked you to look at a family from Brazil that had some children that were normal pigmented. So pigment is the color of your skin. And this woman had, she had 6 children, and 3 of them had normal pigmentation, and 3 of them had a condition called albinism, or they were called albinos. Albino is when you have a different expression of your melanin pigment. So melanin is what causes our skin color. And from the lightest individual to the darkest skinned individual. The mere difference is how much melanin they produce. That's it. So we're going to go into that storyline. So the first thing that I'd like to do, and we're going to do this on page 98, our vocabulary list is over here on 97. I'd like to go through that storyline a bit. So we're going to follow, or we're going to track the trait for the Brazilian family and their study of albinism. So albino children in a family. So we got to put a little bit of information down first. Let's go ahead and make sure we understand albinism. Albinism is the condition that causes albino children. There's quite a few different types of albinism. What we saw in the Brazilian family was a pretty strong presentation of this particular trait, but it's caused by one single gene that disrupts the amount of melanin that's produced. So albinism is caused by one single gene. It's inherited, but the first person who had this particular type of albinism, their gene was mutated. So a single gene mutation inherited in a family that disrupts the production of melanin, which is skin pigment. Okay, so this idea here is we need to represent this family in a graphic. So we're going to talk about the mom and pop, and we're going to talk about the 6 kids, and we're going to organize them in something called a pedigree. Pedigree sounds like dog food, but that's because in the world of dogs, we track the parents of the offspring dogs and the parents of those parents and the parents of those parents. So we go back into a family tree. In genetics, we look at one trait at a time in a family, and then we try and figure out what's the possibilities of the offspring having normal offspring of their own or having children that have the same condition or trait. So for this particular condition or version of albinism, we have to come up with the alleles to represent the trait. So the alleles that we're going to use are going to be big M for normal melanin, and then little m, and we're going to have to do a kind of real low cursive type for the albino offspring. Okay, so let's see what our options are. So our genotypes we'll list here. So we could have big M for an individual. And what would that look like? So that would be a phenotype. Phenotype is the description or the expression of that trait. If you had a big M, that means that the only gene that you have is how to make normal melanin. So that means that you would be normal. If you had a big M and a little m, this one, when you have one of each, only the dominant one is expressed. So that means you would still be normal. But you do carry this trait. We'll come back to that. And then if you have little m, so those are the only alleles you have, is for albinism, then that means you are an albino. Now, let's go back to this. If you are what we would call heterozygous, so the letters are different. Heterozygous over here, big, little. So we have hetero means different, so the alleles are different. If you were heterozygous, the dominant trait would be expressed, which means you will be normal pigmented. However, you do carry this recessive trait. So we say normal, but a carrier. So this is how sometimes we see that particular traits or conditions, they don't always have to be conditions that we wouldn't like to have ourselves. They could just be different versions of traits. Some of those traits are hidden or they are said to skip a generation. And they're not skipping a generation, truly. They're just hidden because the individual is heterozygous and this recessive trait is masked or hidden by the dominant trait. So let's go take a look at this family. I'm going to go ahead and ask you to hit pause on the video after I give you a little bit of instruction. I'm going to do the exact same thing. And what I would like you to do is I want you to try and consider what would a family tree look like for this particular family in Brazil. So there's a mom and a dad, and then there were 6 kids. And we got to consider the order of the children. And I'd like you to make the females circles and the males squares. That's a classic way of doing these particular graphics. So think about that, and then I'll go ahead and draw one for you. We'll draw one right here, but you don't have to draw anything, but just try and picture it in your head. If we were going to look at the 2 generations in this storyline, we're going to look at the mom and dad and what maybe possibly their conditions are, and then those 6 children. Okay, so we'll stop here.